9. Turn on your cameras, please. Cameras on, please. Sige, turn on your cameras. Okay, class, can you see the board now?
Yes, sir.
Okay.
Yes, sir.
So our topic for this afternoon is not a new topic because I think most of you are familiar, with welding. So welded joints are very common methods of joining two metals together. You will see this in uh, most of the structures in houses, around they're using welding to make trusses, steel trusses, but also for machines, okay? Especially that welding is used for metals. Okay, so even if you have not experienced actual practice in the laboratory, but at least you are familiar with welded joints. Okay, now welded joints is what we see is actually a fusion welding. Okay, when you say fusion, ako nang binisayon, kanang mutapot na siya. Okay? In other words, okay, I'm going to just summarize this in our vernacular. If you are going to weld two metals together, kung imo nang isumpay by welding, if you are going to join this by welding in this way, these surfaces here should reach a fusion temperature. Meaning, malanay ni sila nga magtapot. Ha? Malanay ni imong mga surface niya magtapot sila. So, integrally, isa na ni sa ka-metal. Atong kuan. Although there are welding rod, a different metal that is being used to fuse them, pero mo na ang may tabo sa fusion welding. Kinahanglan mulanay ni siya nga magtapot sila. Nga isa na sila ka, one piece na sila. Okay? Dili na nimo ma-separate ang kuan kay ni sagol man ang mga metal materials. That is what is known as fusion welding. The edges of the part are heated to fusion temperature. So kinahanglan fusion temperature, meaning mutapot na sila nga temperature. And then join together with the addition of molten filler. So naa ni siya ibutang ko dire in between nga filler, no? So then we need some methods of heating this up para malanay. Okay? So heat is obtained from either an oxyacetylene flame or the most common is an electric arc. No? Gikan sa kurente. No? That is the most common. Electric arc, and then you have an electrode. So basically, you have two metals here. You heat this up into fusion temperature field. You fill this up with a filler material. Okay? Filler material, which is the welding rod. We call it the welding rod. So if you have seen a welding rod, na siya metal part diha nga mo na siya mo sulod dire in between. Okay. Any question from those who are virtually attending the class? Wala?
None, sir.
None. Okay, good. So, there are only two types of joints in fusion welding. The first one is, if you are going to join this together that way, you will notice that the surfaces are parallel. It's called a butt weld. Kabalo mo sa ng butt? B-U-T-T? Anong gasmahil mo? Because that is how it got its name, no? Minsan ang B-U-T-T. Imong lubot, no? Mulingkod na imong lubot sa lingkuranan, parallel na sila. So, muna ikuhaan yan ng butt weld, no? Mura man siya lubot ba, nga nilingkod, sa asa siya nilingkod. Ang surfaces that are in contact are parallel. It's called a butt weld. So, although there are, maybe if you look at a dictionary, it's not only butt nga kanang as or lubot, no? But maybe there may be other terms associated with butt. Pero muna siya, butt weld, the surfaces are parallel, sumpay. The difference between a butt weld and a fillet weld is, the fillet weld, the surfaces are perpendicular. Ana, kini nga surface o kini nga surface, dire sa taas na surface o dire sa subos sa surface, muna imong i-join together. Okay? So, as illustrated here, you will notice that not necessarily parallel ang mga surfaces. Initially, parallel na sila, pero ato na siyang champiran. Ambot, I don't know if you V-cut, no? You form a V-cut so that you can insert the welded materials. Kaya, og imo ra na siyang iana, ang sa ubos dili ma-penetrated. So, you cut a V-cut and then you start from the bottom. Kita. Okay, so if the surfaces are this way and then you weld from the top, dili makabot sa ubos. But if you chamfer it that way, you start from the bottom, filling this up. So sugod ka diri weld, antod ma-fill up nimo dahil iburot. It's always kuan na siya, is open ang naiburot diha. Okay? It is a reinforcement. Okay? Now, you will notice that the weld joint is in this direction, and then you pull this. Of course, you are going to stretch, no? You're going to stretch the welded portion. So that's why this is in tension. Og imo po ng balihon is in compression. Okay, tension ra gibutang diha. Now, if you pull this apart that way or this way, what will happen to the adjacent metals? It will slide this way or this way. So what kind of stress did the welded portion experience? Shear. Okay, so you will have shearing here. Okay, now in computing for the stress area, we do not consider the reinforcement. Okay. Kini man tanang stress area na. But actually, in reality, dili na nato, we do not include that because if it will fail, it will not fail here. Kaya dako man siya. It will fail somewhere here. Kaya ang failure ano niya is in the smaller portion. So that is why in the formula for stress, we only use this. We do not use this one. We do not add A. The A is the reinforcement, no? The height of H for a butt weld does not include the bulge or reinforcement A. So we do not consider this in computing for the stress. So again, tensile or compressive stress is force over area, which is H times the length. Now for a butt weld in shear, it's the same. Force over area. Ano na gyapon? Ato area. No, we do not include the bulge. Okay, any question? Wala question? So let's proceed to the fillet wheel. Now you will notice that it is perpendicular, no? The surface are perpendicular, and this is your welded. This is your weld material. No? The surfaces are perpendicular. Kaning surfaces sa butt weld are in parallel. So the throat area is actually the smallest area in that portion of the joint. Now for this one, ang throat area, nga naman, how did you nganong nakakuha mo tag term nga kanang throat area? Kakuan mo nganong, do you have any idea why? Why it's called a throat area? Ha? Oh, lagi nganong throat man? Ugma pag nganong throat. Okay. So actually this is my only logical thinking, no? The throat is the smallest area in our body where you kill a person, di ba? Yung tukon sa throat, no? It is easier to because it's the smallest area. So murag diha ang logic. But actually, that is also true for bottles. Mga botelya, di ba? Ang botelya, ang smallest portion of the bottle is the throat, no? So maybe that is how it got its name, no? So the throat area is the smallest or minimum cross section. So for here, the minimum cross section is of course this H times L. Now for this one, you will notice that this is H and that is H. But if you take this times L, this is even smaller. Now this is even smaller. So that is why the throat area is not H, but a component of H, which is what? If this is for 45 degrees, how much is this? So H times cosine of 45 degrees. Okay? So the throat area is 0.707 times of H. Actually, I'm just using this sa because this is what you will see in your PDF files, 0.707. But if we follow a more significant figures kay tulo ra man ka significant figures dire. If you will notice sa atong kuan tulo ra man. Actually, if you will recall, sa 45 degrees, can you remember this in your trigo? This is special triangle. This is 1, 1. What is this? Square root of 2. Okay. The ratio of the hypotenuse to the any of the sides. More gyapon kini ang hypotenuse. Ratio is what? 1 is to square root of 2. You compute that. It is 0.707. Sakto? Okay. So, actually, I wanted to use this here instead of 0.707 to have more significant figures. Pero that is what is being used in the textbook. So, I will just stick to that, no? I'll just consider that. But for more accurate, more significant figures, 1 over square root of 2, unta ni siya. Okay. So, of course, you have your affiliate weld intention wherein this part of the weld will be stretched, mainat siya, no? But most of the cases and fillet welds, they are in shearing. Ma-sheared sila, no? Like this one. No? You will notice that it's pulled this way and this portion is pulled that way, and you are going to shear your fillet weld. Okay, shearing stress is P over throat area, 0.778 times the length. Okay? Again, stresses are calculated for the throat or minimum cross-section located 45 degrees to the legs of H. Laghanig mga, ano? Laghan og mga terms dere nga kuan kanang parts of our body na ibat na po legs. Okay, but anyway, that is the throat area. It is the minimum cross-section. Any question? Class, any question?
Wala pa, sir.
Lara. Okay, let's proceed with. By the way, last time did I ask them to take a screenshot? Basig na. Wala ka screenshot, ha? Last time? Ngayon ko nga, screenshot kaya basig malimot. You provide kato naka-picture dire, no? You provide them with one. Okay. So let's proceed. Now for static loads. Okay. For static loads, meaning not fluctuating. Static, not fluctuating. Na-appeal ba ni sa inyong kuan? Sa inyong exam. No? You have your steady, and then you have your fluctuating loads, and then you have your theories of failure. No? Then katong kuan, modified Goodman diagram is actually fluctuating ito siya, no? That's fluctuating loads. And then for brittle materials. Okay, so review hato. There are only three problems. Okay, three raka problems. But don't worry. Di ba naman ito stress concentration? Don't worry about the graph. Okay, I will give the value already. So you don't have to worry about the graph kay, di ba? Naman to ikuan nga ug makini kini ang R, kini ang D, small d ug capital D, ana itao ninyo ang K. I'm going to provide a K aron kuan uniform tatanan kay it will be approximated manggod. So those are some, and then also another one is there's a problem there that I'm going to give the element. I'm going to give the element. So you should be familiar with the Mohr circle again. Okay. Atong element, for example, I'm going to ask, I'm going to give an element and then say, if you are going to apply the maximum shear stress theory, okay, and then, so kinahanglan, kabalo ka, unsaon pagkuha sa maximum shear stress? Based from the element, no? And then the last one is a fluctuating load. Fluctuating load. So, mura na siya, moral, mga tips na kung ako anit. Tony. Nakakuha mo diha? Those who are following virtual?
Yes, sir.
Okay, sige. So, for static loads, balik na po tayo eh. Factor of safety is yield point over the actual stress. Now, for shear, it is 1/2 of the yield point in tension. Kini? The yield point in shear is 1/2 yield point in tension over the actual stress. Now, for compression, it is the yield point in tension over the actual stress in compression or tension. Okay, static. For this afternoon, murag mubo ra sa atong kuanon, no? Kay di maigo tanan, no? Because the next example is quite long, so dili maigo sa blackboard. Okay. So what we have here is a fillet weld. So fillet weld, yun, ano siya, ha? Ano? So, what we have is a fillet weld, 2-inch long, and it carries a steady load of 3,000 pounds. Now, lying along the weld metal has a yield strength of, so actually, we will be using the yield strength of the weld metal, no? In other words, katong welding rod, the strength of the welding rod will be the one that will be used instead of the strength of the plates na imong gisumpay. So this is the yield strength of the welding rod or the weld metal. And then we are going to find the factor of safety. Okay? Now, how do we imagine this? Wala may figure. Wala figure.
Nag-story ako sa fb.com ko ng first time ko.
You have a fillet weld, 2-inch in long. The question is actually how is it loaded? Anak ko no. Anak, dayon na adere. Nadere imong fillet weld. This is 2-inch long. How is it loaded? Asa man pa ingon process nimo?
Downward, sir.
Payon silong, may taas?
Patilong, sir.
Ha? Meaning, you pull this downward and you pull this upward? When you say, now what is the idea? So this 3,000 pounds is lying along the weld.
What the hell?
In English, rabane, sabutane. Now, ngayon siya nga, namakak siya along the weld, di ba? Lying along the weld. Or actually, it is in the direction of the weld. No? So the forces are actually in the direction of the weld. So if this is your weld, and this is your length of your weld, so it should be in this direction. Okay? So, unsa man mo? How are you going to? What is the most likely kind of stress that the weld metal will experience? Of course, you pull one of the metal. Now, in the direction where it is lying, and the other in the opposite direction. Kaya yung dirahon niya, walay. If you pull this in the same direction, there is no stress. So you pull this in this direction, and you pull the other side in that direction, then your fillet weld will experience what kind of stress?
Shearing, sir.
Okay, shear. Okay, so wala siya na makak, ha? Lying, wala na makak. But it is okay, siya. or in the direction, no? In the direction of the 2-inch long length of the weld. So basically, ito yung graph. Naman ni dire. No? Actually, this is the reciprocal, ha? Reciprocal of 0.707 is 1.414. This is actually square root of 2, maning 1.414. So if you try to find. So, this is actually force over area. This is actually 1/4 times 0.707. Pero gibutang rang 0.707 diri sa taas na imo 1.414 times the length. Okay, so it is 8,484 psi. That is the shearing stress on the 2-inch welded portion. Now, factor of safety is the yield point in shear, because this is shearing, yield point in shear over the actual shear stress. So, yield point in shear is actually 0.5 yield point in tension. Okay, remember this is yield point in tension. Yield strength gani automatic na siya, no? Yield point in tension. Okay, so you will have a factor of safety of 2.946723. Any question?
Ay, sir, excuse me, sir.
Yes, go ahead.
Ano ganito na 1/4 ni sir katong sa answer 1/4 times 2?
Asa man ang 1/4 times 2, ana?
So kanang T equals 1.414 times.
Unsa may kuan? Unsa may shearing stress is force over throat area. Di ba? Do you follow this?
Yes, sir.
P is how much? P is how much?
$3,000, sir.
3,000. Tubag dayon kay aron madali ta. Okay. What is the throat area? What is the throat area?
1/4 times 2.
1/4 times 2. But
H,
this
sir.
1/4 is the H. This 1/4 is kini. So is that the throat area? Huh? Is that the throat area? Kini?
Yes, sir.
So, you mean if this is 1/4, this is your throat area.
Yes, sir.
Huh? What is the throat area? According to the definition there, what is the throat area? What is the throat area as defined here? Huh?
H cosine 45, sir.
H cosine 45. Dili, H. So, we'll go back to this one. What is our H here? What is our H here? Sorry.
Answer H cosine 45.
Lagi. What is our H here?
1/4.
1/4. Ang L? 2. So, kumplito na siya. Muna na yung throat area.
Yes, sir.
Dili, sir.
Dili, nga naman.
Walay cosine 45, sir.
Wala yung cosine 45. So, what is cosine 45?
0.707, sir.
0.707 times 1/4 times 2. But actually, in the formula, we take the reciprocal. Butang nato ni siya sa taas. Muna siya na imo 1.414. Do you follow?
Yes, sir.
Oh, na dito. 0.707 H times L in P, and it becomes 1.414 P over HL. Come on, do you follow?
Yes, sir. Yes, sir.
Okay, sige. So, wala na tayo problema ani.
Wala na, sir.
This is the 0.707 dire sa silong. Ipasaka na siya. Okay. So basically, that is an example of a fillet weld in shearing when the load is static, meaning there is no fluctuation. The next topic, which is actually, I just write the summary of how to do it, is when the weld is loaded eccentrically. Wala kay balaga ng eccentric loading? Ha? Sa previous na ito nga kwan, hindi mo kadumdum? When the load is eccentric. Wala? Or any other term nga makakuan mo nga una-una mo kabahin na ng eccentric, unsa man na siya? Mengga ka ng tao, eccentric na siya. Ha? Weird. Oh. Very normal. So just like here, when our loading is eccentric, it is not normal. No? Because the usual way of loading it is we load it sample.
Ay, sir, excuse me, sir.
Yes.
Ang camera, sir, dili. Wala na ako, sir.
Ah.
Thank you, sir.
Okay. Thank you, Paul. When we load this, the normal way of loading it is dire. Now, if we load it here, dire skillet, dili na. Normal. In fact, atong example, na anak na ito. Dire ang atong computation, pero ang atong load dire. If it is not eccentric, ano yung atong load dire? Naman dire. So, in general, I would say that eccentric loading, this is general, no? When the loading does not pass to the center of gravity. Umuagi galing sa center of gravity on sa man. Okay, concentric. O, di ba? May concentric. Asa man na? Di ba? Kuan sila, kanang align sila, nasa tunga ni agi. So, when it is concentric, mo na siya ang atong usual. But eccentric is dili normal. So, narabapod mo yung parang nga mga keywords ba? No? Para sa mga bat, no? Eccentric, kung sa inyo mauna-unaan, doon na siya. Okay. I'm doing this so that you can remember. Okay. Now, may association ba? Nga, isa lang ito, eccentric. Kuan man to kanang dili man to normal nga no ganito. Okay, kuan na mo, kadumdum na mo. Now, eccentrically loaded welds, the effect of the moment and the direct load must be taken into account. There are, if you will notice, no, atong anak na itong kuan. Itong anak na ito nga Bira ba to siya dire ana? Or bira ana? If you try to notice, we cut this and it becomes a ana nga load o ana nga load, no? Then sunod, this will now be kana og kay kini siya kining duha ana man na. Diba? Ana man na siya. So, kini po siya will be that way. So, in eccentric loading, we cannot directly calculate the stress on the part because wala man gaagi ang atong load on the center of gravity. So, we have two components. This one is, unsa ganito may nga component? Moment, okay? Ang pagkuhan is, ito to? MC over I. Kini? Oh, P over era. This is direct, we call it direct load, and this is the flexural load. However, for welded joints, mao gihapon. Eccentric loading gihapon. But this time, instead of flexure, the joint will be twisted. Malubag. For example, this is your joint, and you try to load it here. What will happen is, you weld this one. No, you weld this probably here and here and here or around. Fillet weld, no? Dili ko di bat weld. Okay, well, kini man siya. This is perpendicular, surfaces. Kini nasa liyon ako. O nasa liyon dire. If the loading here is in that direction, what will happen? It is going to twist it. So, the actual stress is shearing. So, dili ta mo MC over I. But, isa man itong shearing stress due to twisting. Torsional, which is itong sa shaft. Isa man to. Due to twisting of the shaft. TR over J. So instead of MC over R, TR over J. Kanya, silbi kini load dire ato ibalhin na siya dire. Dayon na siya twisting. Okay? So, there are now two components. We have the direct shear, which is force over the throat area, total throat area of the joint. And then, moment or the twisting shear is TR over J. Kini siya mo murag complicated in jutay. Because we will be looking at a certain portion in the welded joints na pinakadako of twisting shear. And let us say, ang T is the same. Ang T is the same for all the for the joint, the same. Ang J is also the polar moment of inertia of the whole welded joints. Parehas ra. It is actually the R that will determine. So meaning, the portion of the welded group man siya, no? Which has a longer R, has a bigger twisting. Okay. Kani siya, okay, parehas naman. So, ang R, okay? Now, so that is why the maximum torsional stress is the farthest point from the center of gravity. Kining R na to is the center of gravity, no distance from the center of gravity to where you want to evaluate the twisting shear. So, kinadakan nga R, maximum torsional stress. Kinadakan nga R, farthest from the center of gravity. Now, ang sunod ani nga problema is the polar moment of inertia. Kini gid siya may pinakakuti. Why? Because we are now talking of not circular, but rectangular areas. rectangular areas. Ana, ang atong area is dire straight, dire straight, dire straight, or probably direra o dire. No? Giweld na ko ni sa diha o diha. So, what is the polar moment of inertia of these two? About its centroid. So, sayon raman pagwag determine og centroid og kini ra og kini kay naaman sa tunga. However, og kini nana nang complication diha ron. Okay, what you are going to do is you find the center of gravity in this direction and also in this direction. Example, ana ang imong weld, dayon ana po ang imong weld. Asa man ang center of gravity ani? Dili po dire, wala ba dire, no? So, you sum areas about dire. Diba? Katong kon ba? Makuha nimo ang iyang kini. Dire na po ka. You sum areas reference mo ni makuha na po nimo ang dire. So mo na location sa center of gravity. If it is not symmetrical, no? Okay, but anyway, we will have the example. We will have the example. Next meeting na lang kay taas-taas mag-go the example ani. So, the polar moment of inertia is you are going now to transfer. Paras ba atong composite one? Kaya nga no, ang polar moment of inertia of mga rectangular man yung atong mga areas ani, ang polar moment of inertia of a rectangle is kini about its centroid. Na remember na man reference centroid ya. Area length squared over 12. Murag base cube over 12, no? But this is base cube over 12 is for I. This is for polar moment of inertia. Truth area L squared over 12. That is about its centroid. Pero kining J dire dili ni about its centroid of just one portion. Example, na gaana nga weld, na po'y gaana nga weld. So kini siya, na siya J about its centroid na siya J 0. Kini po siya na po ni siya ikuan J 0 po sa iya. It is computed by this one. But we are going to transfer this to the centroid of the whole group, which is probably somewhere here. How do we transfer it? Kung parang siya po sa katong I. Pero na I R squared. Y squared doon dito. Na I siya. Okay? So, kini siya is only for one. Example, kini, may balhin dere. Mano siya. Kanina po, may balhin dere. You will also have another one. Okay? So, again, J is the polar moment of inertia of the whole group. Whole group rin siya because unless isa ra kabuk atong weld portion, example, ana. Si ana niya, diha ra. Di na ra diha centroid. Nara po diha. Kompleto ra nato dito ang J. Nga A L squared over 12. O nara siya diha. Wala problema. Dahil nakuno dire ang kuan. So mo na dayon atong J. Dire. However, ug manay madugang dire nga laing weld. Kato imo pa tong ikuan, you have to find first the centroid of the group. Then transfer its polar moment of inertia kay about its centroid man eh. You transfer it to the polar moment of inertia of the group. sa centroid sa group mo na gihimo dire. Okay? Basically, that is what will happen. Okay, so R is the distance, huh? R is the distance between the centroid of one of the weld to the centroid of the whole group. You make sure nga you follow this, no? Okay. Next time, ang problem naman ako isulat dire taas mo gud ang problem. Nang dili ko ka kuan ron, dili ko ka present ron. Okay, you take your screenshot. You take your screenshot. Class. You take your screenshot, class. Class?
Yes, sir.
Mana?
Yes, sir.
Okay, I'll go back to the other side. You take your screenshot. Okay na, class?
Mana, sir?
Mana, okay. Sige. I'm going to ask you again to turn on your cameras, and then I'm going to give you a introduction of the problem. Huh? I'm going to give you an introduction of the problem. I'm going to erase a portion, and then I'm going to, so pagkuha na mong picture. So turn on your cameras, class. Sa next meeting, no, and at least di na mo kay mahadlok ba pag next meeting na. Dili ra kuan ra kanarang murarag. Dili naman di man ako maapas og kuan. Sige, turn on your cameras, please. But don't leave yet, no? I'm going to explain what is ang sunod na problem. We will discuss the next problem. It is actually how do we do this, no? Okay, turn on your cameras, please. Okay, turn on your cameras.
Your bottom tower is under attack.
Dali lang ko ma-illustrate. Kinsa mo volunteer og erase. Erase ra rin ka. Sige. Dire. Kinira nga board. Erase. Oh.
Static loads. Eccentric.
Asa may sayo ninyo paano? Dire o dire? Dire na lang. Oh, manaman mo no, kumana mo kuan. Don't leave class ha, kay I'm going to just show you the outline of what is the next one. Because surely this will come out in the exam. No? Siguro na ako na siya, so last exam. Naago na siya. Mo-review mo sa inyong how to find the center of gravity. Because ang centroid sa group of welds has to be determined. Kaya dito man ka magbase sa imong eccentricity. Okay, remember, when it is concentric, kabalo ka og asa ang center of gravity. Kanya, mawala maiko dito sa center of gravity itong load, eccentric siya. So first, you have to know where is the center of gravity. Okay, class. Makita pa ninyo ang board, class?
Yes, sir.
Yes,
Okay, I'm just going to outline, no? Outline. So, aron, dali na ninyo masabtan ang next one, outline. The problem looks at something like this, no? So these are two plates. This is one plate on top of the other. Huh? Ana na siya, gaana. Gaana. Ha? Gaana. And the welded portions are, so kini siya dire, mga edges, no? This is welded. This is welded. And this is also welded. Pero dito ni Sir sa luyo, akong i-kuan, akong dili na ko i-solid. Meaning, nani siya sa luyo, ano yung kuan? Itong plate. Nang anak man na siya. Anak. So, dire, o dire sa luyo. Kita, class? Ha? Ang weld na to is nadire, o nasa luyo. And then our loading is somewhere here. Okay. So, is this an eccentric loading? Okay. Obvious nga wala siya sa center of gravity. So the first part here is how to determine the center of gravity. So what is the center of gravity in terms of kanang kuan? Because we have to find the center of gravity kanang it has to be located. Ano? So within this, asa man ang imong center of gravity? Huh? Is it somewhere here? Is it somewhere here? Ayan lang sa ng anak, kanang anak lang sa. Ano man? Okay, it is a mirror. So, if you summation moments, you will have the same. So, nasa dito nga. Ang center of gravity. However, og ana, it should be somewhere where? Dire. Nga naman, nga nang dili sa ubos. Okay, you do not have any here. So your center of gravity should be somewhere here. Now, ug makuha na po ni, mabali na po na siya, mo-erog ni. Dili naman ni siya sa tunga, di ba? Oh, mas komplikado na siya. Duha na kabuk imong kuan kini, maditso ra man imo dahil kuan. Nga akin ni sa tunga kay parehas man ni. Kanira may consider. So that is the case. So now, our loading will be something like, on these welded joints, will be now 2, composed of 2. Ato ni siya ibalhin dire, passing through, niya ang anak naman ni siya, no? If we do this, wala man tagihimo. No, we did not, because this one is equal to that one, so wala rin kaso. And these two here is a couple. So, ana na siya. Mana na siya ang kwan. Can you remember this? Naaman na sa inyong flexure. Mora gihapon na siya. So that is what happens. You have a component that is twisting this, and you also have a direct component pushing it downward. Okay, so maoni siya. Mara guday diha atong ikuan. Maoni. Mara guday diha atong giris. So we have a direct shear, and we have a twisting shear. Two components. Now, the twisting shear is PR over J. While twisting na siya. While the direct shear is P over area. Throat area, ha? This is a fillet weld, so 0.707 H times L. Kani, napaka is 0.707 H MBR dire.
Excuse me, sir. Camera, sir.
Okay. Sorry. So, again, as I have mentioned, we now have, akong balikon to, no? Sorry. Originally, naadere ang iyong load. Do you follow? Nakadumdum mo, ani? Class? Huh?
Yes, sir.
Okay. So, what we do is we transfer it here, passing through the center of gravity of the welds. And then, these two is actually a couple nga ana. And we represent that with that one. So this is now your loading, which is made up of two components. This one is your direct shear, while this one is your twisting shear. Oh, kadumdum na mo. Do you get that? So for direct shear, it is the force P, and this is your T. Torque na siya, no? Torque T, dili na M. Class, sorry, kay sinong kalimot. Where did you miss something? Did you miss something? So we now have two components. Now, the next part here is San Rene, because P over area. Area should be the throat area. So 0.707 times pila ni siya? 1/4 ba ni siya ka? 1/4 ba ni nga fillet weld, or 3/16 ba ni nga fillet weld? Times 0.707 times that times L. That is for this one. Kanipod siya, napod siya. Yan kinipod. And then you transfer their polar moment of inertia from their centroid to this one. Centroid to this one, centroid to that one. Muna na imong J total. Huh? Do you follow, class? Next.
Yes, sir.
Assuming nga nakakuha ka tag J. T is of course katong P times that distance, di ba? Atong dire ba? Kana nga distance kaya atong managibalhin. Kining T is actually the katong manang couple. So the couple times the value of P times the distance between the couple. So P over truth area mo na direct shear. How about the twisting shear? TR over J. Again, ang J na to is binagsaon na to ni. J niya is A ito J L squared over 12. Dire pa na siya kanang A L squared over 12 plus yung distance. Kaya naman na J-O man niya, G-O, kining na dire sa centroid niya. Ay yung kadiha mo na imong R1. So imo nang i-transfer from here to here. That is for this weld alone. The other side also. Now since they are symmetrical, pwede lang imong i-multiply by 2. Kini po siya. Yeah. So now that is the total J. R nga, kuan. What is R? Distance between the centroid of the weld to the group. So, actually, ang R mo is from here to here. So, you are going to use what? Depende yun sa dimension ani. Oh, depende sa dimension ani. So probably this is triangular naman na siya. So you determine the hypotenuse. R is from the centroid of that weld to the centroid of the whole group. Any question? So that is how you get your total J. So naanakaling duha. You have computed values for this.
Ano pa si Pera niya ma?
Your
Disciplina.
twisting shear
Pila.
is dependent on
Ha?
T is mo naman to, gikan dire pa indirect. Ang imong J, mo na to, na-compute na nimo. How about R? Kini nga R ha, dili ka tong R gani ha. R1 ba to? Not this one. This R1 is the distance from the centroid of the individual weld to the centroid of the group. However, kining R, lain ni siya. TR over J. Isa man tong TR over J. Oh, for a shaft, the maximum R is on the surface of the shaft. So it is the distance from the centroid of the shaft to any part of the shaft. Ganahan ka, no? Nga, kuan. Maximum is of course on the surface. So, kini siya ron, let us say, na ang imo centroid dire. You want to find the stress here. So this is your R. Ini nga R. Huh? Where you want to find that twisting shearing stress here. That is your R. Can I figure given? Ang figure is given. But that is not the easiest part. the hardest part here is which part is the maximum. So asa man ang kaning direct parehas naman siya tanan. C over A raman eh. But this one, it is determined by R. So asa man ang maximum nga mo kuan og R? Asa man ang maximum nga twisting shear? Pila unsay value sa R nga mo maximum ang twisting shear? Pinakalayo sa? So it is either here na naman isa sa tunga
Kung nasa taas kasi siya,
or the other side here.
yung itsura niya, di ba? Dito sa Pilipinas,
Ha?
wala pa nakikitang gano'n. Kung meron talagang malaking
Class, are you following? Those who are virtually
bawang may makita kayong uod.
sa marira ni siya sa next time.
Yes, sir.
Kasi yung mga uod,
Okay. So, now in each point, in analyzing, we now have two components. So, bisan asa ani, na yung direct shear. Bisan asa po dani, na po ng twisting shear. Pero atong pagkitaon, asa tong maximum. Okay. Now, remember, ana man ang atong twisting. So, what is the direction of your shearing stress because of this one here? Direction of the shearing stress. Kaya doon sa siya.
And here's me
Kung payon ana ang imong, payon ana ang imong torque.
show fans who feels like they've learned something about
Ang imong shearing stress, asa man payon? That is the reaction. But the acting shearing stress is also in that direction, which is should be perpendicular to the mana dire, it should be that way. Kung mana dire, it should be that way. So, if it is here, asa man sa paingon? Perpendicular. So, kana perpendicular na. Dili no, dili. Akong gihimong obvious na dili. So, this is your radius and this is your doon na nas perpendicular. Okay? How about here? Okay, akong approximate ga doon nas perpendicular. Wala gana gamay. Kana. Perpendicular. What is the direction?
To the left.
According to our
Twice.
torque, it is for this one. Asa man pa yun? That direction. According to this, akong parehason sila kay the same TRJ man eh. Kanan, di ba? TRJ parehas. So, probably, yeah, anak siya.
You can check Knievel's mailbox for coupons and samples.
Now, which of these are you going to choose? Of course, if it is only by twisting here, parehas sila. However, there's another component which is the direct shear. Asa man paingon ang direct shear? Oh, downward. So we also have another direct shear. And also have another direct shear here. So asa man ang mugawas nga dako ang resultant? Okay, ang resultant ano niya is this one. Diba? Ang resultant ano niya is this one. Diba? So asa man itong analyzon? Kini. Basically, muna siya ay summary sa next meeting na ito nga discussion. Aron, gamay-gamay na lang mong pangutana.
Got it from his neighbor's mailbox. That night it was good for $90. So you spent $900 at Red Lobster.
Class, those who are connected virtually, na may question?
Honey, play on private. Let your friends hear it. One box. Okay, Mom. Why? I'll do that.
Any question? So, kung dili ka mo kabalo mo, pangita sa center of gravity, you start now. Okay, taas-taas pa inyong. That is why I am saying, actually, atong mga exams is cumulative. So, God's primero, magsumpay-sumpay ra na sila.
Why is this guy locked up like that? Because he doesn't have an eye color. So for example, if you don't have an eye color, you'll be considered.
That's generally the trend in engineering, no? Kinanglan kabalo kag trigo, kinanglan kabalo kag algebra, kinanglan kabalo kag calculus, kinanglan kabalo kag dire, importante kay ang statics. No? Ano?
No reason.
Okay, any question class? Paano rin? But next time, I'm going to present the solution. So, pero that is the summary.
That's why my mom told me to put on these glasses.
And I hope nga, you will appreciate nga ako mong itudloan daan, no? So the first part is to determine the center of gravity.
Why don't you just take off your glasses? Because I'm scared. I don't
After
want to
that,
wear my color. Don't worry, just trust me. Take your glasses off.
you can compute, para makapuntos mo, you can compute the direct shear. Agad naman ay point, di ba? Bisag one. Direct shear is force over throat area, ha? Basic. Yung area na po niya, wala mo. Remember, this is a fillet weld. So, na ito, isa man. 0.7 o 7. Or if you want, that is 1 over the square root of 2. So, mana siya. So, nanakada ay 1 point sa direct shear. Ang sunod is to determine the center of gravity of the whole group. Okay? Of the whole group. So, nana to kay 1 point, ana. So, make sure nga, after that, ang polar movement of inertia na po. Di ba? Polar movement of inertia of the whole group. Which is, you transfer the polar movement of inertia of one weld to the center of gravity. Muna katong A L squared over 12 plus R1 squared. Ano siya? So once na-transfer na mo, na kay J. So at least, naana ning duha. Pero kini, importante. Basig dire ni mo imong R kay nakayong kal kini mo kinadakan. So or probably daka dire kay parehas sa silang duha. It should be here, no? Because this one will give you the maximum resultant twisting shear.
Yung stream water na ipinasa bilang sample, yung pala.
So, unsa man?
Analyze nyo na ba ito?
If you are looking for a gift,
Once napay lain day, which is probably the biggest the biggest catch. Ang kinadak-an siya og puntos. How you determine this? You just naman siya mechanics. Pero depende ha kay this is a little bit complicated kay perpendicular na siya. Ang given ani ang mga dimensions biya sa kuan. Ang mga dimensions siya. Ang mga dimensions, for example, like kini siya, this angle is actually this angle, sakto? Sakto? So, kini nga angle, kini nga angle, kini nga angle. Sakto ba? Sakto no? So, if this angle is that angle, you can get this angle based on this dimensions here. Ano man yung dimensions? Kaya kung naman ka sa center of gravity, nakabalo naman ka, pila ni. So, you resolve this into components. One component. So, kini, sine of this angle is equal to this one. Plus, kini. Yeah, squared. kay kuan man summation forces vertical at summation forces horizontal man ta.
Message niyo ako sa messenger. They
Of
say
course,
join to
unaay
direct.
ganahan
Paano
kuan
chat
ganahan
mo kung
katong
pagkantiin?
kuan you use this triangle
Walang ladi ngayon.
para isa na nga method.
Isang buwan, kailangan mo lang ng 48
No?
hours.
Ang itaw ni mo ni mga angle ani. And then you use cosine law.
Hi guys.
Pero ang pinaka kuan good standard yun nato is you break down into its components. Itong parallelogram method. Parallelogram method, yan na. Kabalo ka ani, kabalo ka ani, kinahanglan.
He said, Molly, what are you doing here?
Ang tao ni mo ang kini.
I won't give you a cent. This was too much. I started crying.
Mas kuan to siya, mas puti.
I came here because I
So,
missed you so much.
ang method ani is,
My dad's stepdaughter laughed.
ano na lang ang component,
Stupidest lie
plus
I've
kini nga
ever
component,
heard. Only
all
kids
vertical
would believe
component
that.
squared,
It's not a
plus
lie.
horizontal component squared,
I'm
wala
only
na
here because I
mag-discuss
missed
ani.
my dad. Dad, please. Why won't you believe me?
That is basically, one, base, muta na pag factor of safety, at least kabalo na ka sa steering stress.
To his stepdaughter. I'm now the father of this smart girl. Do you know why I love Rose? Because she's the smartest person I've ever seen. She's going to be
Ang welds na ani is 1/4 inch.
and she'll go
Pellet
to
welds,
school
kini,
to the
down.
most successful doctor in the country. And I'll be so proud to be her father. Rose gave my dad a hug, giggling. Dad, do you know what my plan is? I'm going to be the valedictorian in med school as well. You're the only reason I can afford to go to that school. That's why you'll be the first person I will thank when I give my speech. I'll go, Dear Daddy, if it weren't for you, I wouldn't be standing on this podium today. And you'll be the proudest dad in the ceremony, she said.
Wala mo na akong gihatlok, ha? Masig mahadlok na mo. I'm just trying to, ano about, warm up your minds, no? So next time, manana ni example, basig mo ay sayo na di ay.
I am now the father of this
Kaya yung rano.
I would be sobbing when I woke up. I must have dreamed of this scene hundreds of times. That dream drained my love for my dad day by day. Until one day, I was done.
Okay na ta, class?
My maternal grandmother had been bedbound
Class.
for a long time. We would go visit her every month.
Yes, sir.
Mom always said,
Okay na. O, sige. So, I'm going to ask.
my mother.
Okay naman ta, kumanaman mo screenshot. So, you may now leave our class. Ngayon, ako na po ipa-erase. Kinsay ganahan mo erase, kanang exercise ba? Ato, wala pa. Konsensya po mo, mawala pa mo. Ha? Oh, hindi ka man. Sa result mo sa exam? Result sa mo exam? Oo. Napailain o, kinsay ganahan mo erase. Limpiyuhan ninyo kayo aron kuan.